Well, a lot of analysts are extremely passionate about the tools they use, and that's what we're going to talk about next. We're going to look at tools used for a few different aspects of being an analyst: data manipulation, interactive visualization, data science, and what you use to present your work. In terms of data manipulation, I mentioned earlier, Excel has been a staple for years for more manual data manipulation. There are also some point and click tools. Uh, Alteryx does come with a licensing cost, but it's a point and click tool. There is the ability to code within it as well. Knime is an open source, perhaps, or it's at least free alternative that's also point and click, similar to Alteryx in a lot of ways. SQL is an analytics staple. It is a coding language, but it is one of the simplest coding languages you can learn, and it's extremely useful for data manipulation, merging tables together, creating columns, filtering data, all in an automated way. That's one we're going to look at in deeper detail. SAS is probably one of the original advanced analytics platforms. It's been around for years. It does cost money for the license, versus there are some other advanced analytics open source solutions like R and like Python that we're going to really dive into as well. All of those can be used for data manipulation. SQL, SAS, R, Python are your coding options that I would generally recommend pursuing. And then Excel is your most manual of all of them from a data manipulation perspective. In terms of interactive visualization, these tools have become really popular over the last 10, 15 years. Power BI has become an extremely popular option, and we're going to do a deep dive on Power BI in a specific session. Tableau has been around for a long time. They've been a staple in the industry for a while. That's between Power BI and Tableau, those are your two major platforms. But there's also platforms like Click or MicroStrategy. SAS has their Visual Studio, and all of these have at least a paid version that most companies would be using. Interactive visualization tool, it's typically not free. When it comes to data science, you can build your model in several platforms. These are just a few. Python has become a very popular choice, as well as R for statistical models. And SAS, again, has been around for a while. People have been building models in SAS for a long time. That does typically require a licensing fee, while Python and R are open source. And then even in Knime, Alteryx, and even Excel, there are options to build models. But I would highly recommend Python, R, and SAS for the flexibility they provide. When it comes time to present your work, the standard, as it is in many professions, is to build a PowerPoint presentation with your findings. However, it can be especially efficient and perhaps engaging to actually take your visualization in Power BI or Tableau and use that as your presentation and drill into trends live before your stakeholders. One side benefit of this is it also acts as a training session to show your stakeholders how they can dive into these trends as well. Let's get into data manipulation. We're going to start our journey in data manipulation off with one of the most popular data manipulation tools, Excel. In Excel, you essentially have a set of worksheets, a workbook or file that has a set of worksheets, and each worksheet is essentially a data table, or it could be composed of multiple tables, but it's a set of rows and columns. It's a very simple concept that a lot of us take for granted. We've just gotten used to using it so many times. A worksheet can have multiple tables or charts, as we said. This is a Microsoft tool, and so most organizations purchase an Excel license for most employees, and it's been around for a long time. It does provide a fairly flexible means of data manipulation, but that data manipulation is mainly being done by point and clicking. It makes as a result of it being based on point and click, it makes building an Excel workbook a little repetitive not as efficient as coding tools, but it is one of the easiest analytics tools to learn, which is probably why it's so popular. If you want to do advanced data manipulation, oftentimes an analyst has to jump through hoops. It's not as straightforward as it would be maybe with other coding languages like SQL and Python. However, some analysts will learn VBA and create macros to automate some of the data manipulation to some extent. This is one of the tools of choice, I would say, especially for financial analysts and supply chain analysts in general. That's a generalization. And sometimes even your regular analytics analyst, marketing analyst, or sales analyst, especially if they're at a level 1 analytics maturity organization. When an analyst creates a workbook, a lot of times it gets emailed out. Sometimes analyst will create a Python job or a process in another analytics tool that will automate that emailing out of an Excel workbook, which if you're going to use Excel, that's a more efficient way to use it. But once those Excel workbooks are emailed out, usually the recipient has a limited ability to interact with the data, like they wouldn't be able to interact with it to the same extent they would with an interactive visualization tool like Power BI or Tableau. But there are some Excel features that the analyst could use to make this possible. There's pivot tables. There is the ability to create slicers in Excel. That's not done as often, but there are some options out there. Excel workbooks tend to mainly be used for data exploration and analysis. It's very quick to pull data into Excel and manipulate it, so it often gets used for that quick analysis, especially even at the higher analytics maturity level organizations. It's rarely used to create data science models, but there is the possibility to create regression models and statistical tests with either Excel add-ons or certain functions in Excel. Now, where Excel really excels is building spreadsheets where cells and inputs can be changed, and then the linked cells, results, or models will automatically update, especially something like a financial forecasting model or a budget model. It's hard to beat Excel for a financial model. Let's take a look at an example Excel workbook. This is a worksheet within a workbook, but you can see there's an example of a graph here, a table here, and all of this is very easy to set up, and we'll go into how to do that in our next training session. Let's talk about another data manipulation tool, a point-and-click tool called Alteryx. Alteryx is comprised of two different versions, a designer version that an analyst would use to actually create a workflow, and a gallery version that's online that an analyst would use to publish the workflow, schedule it, and publish and access applications. A workflow is made up of chains of different types of data manipulation nodes or blocks. Each one represents something different, like selecting data, filtering data. These workflows are created through the point-and-click designer application. And one of the unique features about Alteryx is this idea of creating an app in the online gallery version. An application essentially asks for inputs from a user, from a stakeholder. It'll run the workflow, the set of blocks in the background, and then it will return the processed result back to the user in the application window in their browser. It's very simple, and it's a great option for automating common tasks that always have slightly different inputs. Alteryx is a popular tool for analysts who want to avoid coding. It does have the ability to write Python code and SQL code in it, which is great, but a lot of people use it to avoid coding. But at the same time, even though they're not coding, they do have the option to automate the data manipulation by putting their workflow on a schedule. This is really popular, especially for level 1 and level 2 analytics maturity organizations. It's not as popular as other options like Excel, SQL, and Python. It does have a licensing cost that is not insignificant, but it's fairly flexible data manipulation. Not as flexible as coding generally, but still fairly flexible. Again, you can You can get that flexibility with the Python and SQL modules within Alteryx. Similar to Excel, the setup of the nodes, since it's done via point and click, can get a little repetitive, a little manual, so it's not quite as efficient as coding options in my opinion. But one benefit compared to Excel is that after initially coding the workflow, it's really easy to automate the workflow on a schedule in the gallery. Similar to Excel, a lot of times analysts have to go through a little more than what's necessary, jump through hoops, and perform many steps to do more advanced data manipulation, in my opinion. Alteryx workflows can be used to create curated data sets that are refined to the interest of the team using them, to email out reports, or to automate manual requests. Some analysts might use Alteryx for data exploration analysis, and it seems to be, in my experience, less often used to create data science models, but it is possible. Let's take a look at a few specific screenshots of Alteryx. So here is Alteryx Designer, where you'd actually build your workflow. These are different nodes or blocks that are strung together. It shows the order. You'd start with this one, maybe import some data, select data, merge data together, and so forth. After designing this in Designer, you would publish your workflow to Alteryx Gallery, which is online, and this is where you could schedule it or set it up as an application where your stakeholders could go and run a workflow that you've created for them. And that's Alteryx at a high level. Let's talk about Knime. Knime is another point-and-click node-based tool. It's a set of nodes that are strung together, as you can see here, to create a data manipulation process. And it's all done via point-and-click. It is free. But even though it's free, it doesn't seem to be as popular as Alteryx. It is somewhat popular for building data science models in a very visual way, which is one benefit of it. It tends to get especially a lot of use for data science by junior data scientists. More senior data scientists would tend to use a coding platform like Python, but it could be used by some more senior data scientists as well. Again, it has a great way of laying out the data science process. Perhaps even more visual than what's possible with code. When you look at the popularity of Alteryx versus Knime, two point-and-click, block-based analytics tools, it's very clear that Alteryx is more popular, at least in terms of Google searches, than Knime. So to me, Knime is a best kept secret out there when it comes to point-and-click block-based data manipulation. So if you're looking for an open source, a free block-based tool, give Knime a shot. SQL, an analytics staple. SQL is essentially a coding language, usually written as a query. It can be used to create tables as well. But a SQL query is made up of several statements that specify which data to pull, what tables to pull that data from, and how to organize that data. In the end, running a SQL returns a table of rows and columns, similar to a worksheet in an Excel workbook. There are different parts of a SQL query, like the select statement, the from statement, where statement, group by, order by, and more. And we'll get into those when we look at the SQL session. For analysts and data scientists, especially at a level 2 or level 3 analytics maturity organization, again, SQL is truly a staple for data manipulation. And the proof of that is the fact that nearly every analytics platform has an option to write SQL code inside of it. That's true for Alteryx, SAS, R, Python, Tableau, Power BI, and more. Now there are several different variations, slight variations of SQL, but the basic components like the select statement, the from statement, the group by the statement are the same across all of them. Just slight variations in things like date syntax and other aspects. Now SQL has traditionally been ran on premises at a company and platforms like Microsoft SQL Server, Oracle, Teradata, and others. But over the last 10 years, big data cloud platforms have created their own versions of SQL, such as Snowflake, HiveQL, and others. This allows an analyst to use cloud computing to apply traditional SQL data manipulation, the same select from group by statements analysts are used to, in a way that can process billions of rows within seconds. It's quite impressive. I would say SQL is especially good at aggregating and grouping data. Nothing does aggregation like SQL does. It's also really good at joining tables together in a flexible way and creating custom columns. You know, in terms of data manipulation, SQL is very flexible. Although, in certain cases, when it comes to looping through data, platforms like Python, R, and SAS are perhaps even more flexible. But again, SAS can be actually ran, SQL can actually be ran within those platforms. Now, once a SQL query is written, it's normally used to pull some data, maybe one time, or schedule another platform to run on a regular basis at a stakeholder's schedule or whenever on demand. It's very helpful for automation. When it comes to one-time data pulls, if you were to get an ad hoc data request, it's very likely that an analyst would go into a SQL platform like Microsoft SQL Server Management Studio, run the SQL query, copy and paste the results into an Excel workbook, and my recommendation would be to create a SQL tab as well that you copy over your SQL query there so it's all in one place, the same workbook, and then email that out to the stakeholder. SQL is often used for data manipulation, maybe some analysis as well. Most data science models, with the exception of things like market basket analysis, can't be used to create, most data science models cannot be created in SQL. But SQL is extremely helpful in creating the starting modeling data set for a data science model. So it is important, especially for the data engineering work involved with building a model, but it's not typically going to be used to actually run the modeling algorithm like regression or decision trees or random forests. Here's an example of a very popular SQL platform called Microsoft SQL Server Management Studio. And this is set up very similar to other SQL platforms where you can explore databases and data tables on the left in an Object Explorer. In the top section here, you can actually write your SQL statement. You have a select statement, a from statement, and group by statements and so forth that we'll learn more about. And essentially, you write the SQL query, press execute, which runs a SQL query, and eventually it'll result in a data table, a set of rows and columns, and you can copy that data to Excel or wherever it needs to go from there, or embed the SQL query in an interactive visualization platform or in Python or SAS or any of the other analytics tools that have a SQL integration. Now, SAS is what I would call an advanced analytics tool. It can be used for data manipulation, but it's frequently used for statistical analysis and building data science models. And SAS also has an interactive dashboarding tool called SAS Visual Studio. This is one of the first and primary analytics platforms available in the 20th century. It was built at NC State by Jim Goodnight and John Saul in the late 1960s and the early 1970s. It's been around for a while, but it has been declining in popularity over the last 10 to 20 years as open source alternatives like R and Python have become available. The cost of a SAS license is not insignificant, and so a lot of analysts have opted for the open source free version of advanced data manipulation. SAS does have integrations with SQL and also even R and Python now, which is very convenient. It tends to be especially popular in the medical and banking industries, probably in part to the fact that regulators have historically had a preference for SAS dataset formats in these industries. And the company is based in Cary, North Carolina. At the bottom of the screen here, we have an example of code written. I believe this would be in base SAS, and as you probably can't see the details here, but SAS coding tends to use a lot of different types of procedures, proc statements. But that's your overview of SAS. Similar to SAS, R is a flexible analytics coding language that can be used for data manipulation and also statistical analysis and building data science models. But unlike SAS, R is open source and free. The R language is usually coded out and ran in an IDE, an integrated development environment. And the most popular IDE for R is RStudio, but there are others as well out there. R also has an online reporting tool called ShinyR, which is worth checking out. R uses packages that are full of functions for various types of data manipulations and actions. There's packages for regression and different types of data science models and all kinds of data manipulation functions. Now, R has historically been the statistician's preferred SAS alternative, more so than Python. But that seems to be changing as more and more data science algorithms have been created in Python, and often in a more computationally efficient manner than in R. That's a generalization. At the bottom here, we have an example of RStudio, where you can see the coding window, the console, some variable definitions at the top right, and some examples of output in the bottom right. It's a neat setup, a neat IDE setup where each part of the screen has its purpose. And then there was Python. This is a topic that we're going to dive deep into in a specific session on Python. Similar to SAS and R, but even more so as a general purpose language, Python is a flexible coding language that can be used for data manipulation. It's frequently used for statistical analysis and building data science models as well, but it can even be used for developing websites and applications and even video games. Similar to R, Python is open source and free, and also similar to R, the Python language is usually coded out and ran in an IDE. The most popular IDE for Python, though, seems to be a Jupyter Notebook, but there are other IDEs as well for Python. A Jupyter Notebook has multiple code cells, and the output, which might be a table or a chart, a pandas data frame, a variable value, model output, the output from that code cell appears directly under each code cell. It's a very interactive experience coding in a Jupyter Notebook. Similar to R, Python also uses packages that are full of functions for various types of data manipulations and actions. Anaconda is a very popular distribution for Python. It includes the Python executor, the thing that actually executes, runs the code, common Python packages, sets of functions, and the Jupyter Notebook IDE, as well as several other IDEs as well. Python has historically been the coder or the programmer's preferred SAS alternative, more so than R, which I think has led to its algorithms and functions being generally more computationally efficient than R. As I said before, that's a generalization. This is an example of a Jupyter Notebook. At the top we have the title, and you'll see it's made up of multiple coding cells. Each of these is a coding cell, and beneath that coding cell would be any output from that coding cell. Again, a very interactive experience coding in Python in Jupyter Notebooks. Now we're looking at Google Trends to get a sense of how popular these tools are, at least based on Google searches. You'll see overall Alteryx tends to have less searches than the other tools here, Python and SAS. Now, R is hard to get a read on because it's a letter, so we don't have R shown here. But what you'll see is SAS' popularity has declined over time in terms of Google searches, and Python's popularity has really increased quickly since about 2010. It's become a very popular tool for analytics. Now, this is Python in general, which again can be used for things beyond analytics. Let's talk about interactive visualization tools like Power BI, Tableau, Click, MicroStrategy, and SAS Visual Studio. As we said before, all of these generally have some form of paid version, but sometimes in certain ways for certain use cases you can use them for free. Power BI is the dashboard tool that we're going to have a dedicated session for. I'm excited for that. It's not quite as common as Excel, but as a Microsoft tool that's added more and more functionality, Power BI has become just as popular as a tool like Tableau in terms of Google searches, and it has the momentum. It's been increasing in Google searches for a while. We'll see a graph of that coming up. Similar to Alteryx, there's a desktop version for designing dashboards that is ultimately used to publish to an online version where the dashboard is normally viewed by stakeholders. Now, downloading the desktop version of Power BI is free. And technically, it's a .pbix file, can be sent via email to others, and as long as they've downloaded the free Power BI desktop software as well, the recipient will be able to open, view, and interact with the dashboard in Power BI desktop. But it's much more convenient for the dashboard creator to simply publish to Power BI Online and schedule it and send stakeholders a web link where they can always see the latest data. That's typically how it's used. This is where the cost comes in, though. It's a little less than the cost of Tableau, and it is often paid in the organization's E5 Microsoft license. If the organization has that level of licensing, it's included. Similar to Excel, Power BI dashboard or workbook can have multiple tabs. Each tab can have different visuals such as charts, tables, cards, slicers, and filters to interact with your data. Creating a dashboard, it usually starts with importing data and then designating table relationships if there are multiple tables in the dashboard. Then creating calculated columns or measures, uses DAX for that, similar to Excel syntax. And then creating visuals, which could include charts and tables and cards and slicers and filters. Then once the analyst feels good about the dashboard, they would publish it online and they would schedule automated updates. It's fairly flexible data manipulation. And in terms of features, Microsoft, at least for a while, was adding features monthly, which allowed it to catch up to Tableau in terms of functionality very quickly. Dashboards are created via point and click, but updates are ultimately automated and scheduled. The big benefit of a tool like Power BI compared to doing reporting in Excel is that stakeholders, recipients, can easily drill into the data. And what that means is there's going to be less manual back and forth, and it increases flexibility for the analyst and the stakeholder. If they need to see it for a particular geography, as long as the Power BI dashboard has been set up with geographical slicers and filters, which normally an analyst will design a dashboard to have drilled down capability, to have filters, slicers available, then the stakeholder doesn't need to put in an extra request with the analyst to get a version of it for a particular geography. They can do that themselves. That's called self-service reporting. Dashboards are often used to monitor trends, so oftentimes you'll see a overtime chart in a dashboard. If not, it's a great thing to include. Here's an example of a screenshot of a Power BI desktop. This is where you build the dashboard, and again, eventually you will publish that dashboard online and schedule it. This is where your stakeholders would view it, simply by accessing a link that you would send to them. Let's talk about Tableau. Tableau was the original interactive dashboarding tool, and it was previously quite dominant. But Power BI, again, seems to have really caught up with it in the last few months. Tableau was purchased by Salesforce.com several years ago. Similar to Power BI, there's a desktop version used to design dashboards that is ultimately used to publish to an online server version where the dashboard is viewed. Now, Tableau is generally more expensive than Power BI. Rather than the desktop version being free, like it is in Power BI, the desktop developer version actually costs more than the viewer license in Tableau. A Tableau report can have multiple dashboards, which are made up of multiple worksheets. A worksheet is essentially a single visual, like a chart, a table, a card, with an optional title and slicers, filters that might have been added to it. One of the downsides of Tableau is that most data visuals cannot be created directly on the dashboard, but have to be created as a worksheet first and then brought into a dashboard. Compared to Power BI, that leads to more steps being needed in order to create a dashboard often. With Power BI, you can create those tables and charts directly within the dashboard. That's a nice thing about Power BI, in my opinion. Creating a dashboard usually starts with importing data, similar to Power BI, creating calculated columns. Now, these will be slightly different syntax than what you'd have in Excel. It won't be as similar as DAX is, for instance, in Power BI. And then you'd create worksheets, which will be charts, tables, cards, and then drag those. This is the extra step in Tableau. Drag those worksheets onto a dashboard and format them rather than creating those directly on the dashboard. Similar to Power BI, then you'd publish it and schedule automated updates. Tableau, similar to Power BI, has flexible data manipulation, but there are some cases, in my opinion, where you kind of have to jump through hoops to create specialized, unique visualizations. Compare creating a waterfall chart in Power BI versus Tableau. And at least for me, I find it much easier to do that in Power BI. Similar to Power BI, dashboards are created via point and click, and then ultimately the refresh of the data is automated, scheduled in the online version. Here is an example of a pretty nice looking Tableau dashboard. You'll see, similar to Power BI, you've got some graphs, a map here, perhaps that doesn't, there may be some filters, yep, up here. And that's an example of a Tableau dashboard. Now, in terms of popularity, this is very interesting. This is a fascinating trend in the analytics industry. You'll notice that Tableau, wow, they came out of the gate. They've been the most popular interactive visualization tool for a long time. You can see that here in blue, but look at this. Starting, in the mid 2010s, Power BI comes in and ramps up extremely quickly. And in the last few months, there have actually been more Google searches for Power BI than Tableau. Can't you just imagine the folks at Microsoft throwing a big party right around here? Click is another somewhat common interactive visualization tool, but you can see that for the entire time period here, Click has had far fewer Google searches than Tableau especially, and at this point Power BI too. So that gives you a sense for how popular these tools are. Now, with all of the tools that we've talked about, if you know one tool in that area, like if you know one interactive visualization tool or one at least coding data manipulation tool, learning another one becomes a lot easier than certainly learning the first interactive visualization tool that you did or the first coding data manipulation tool. So if you can just learn one tool in each area and master that, if you're applying for a role that maybe uses Tableau and you've used Power BI in the past, learning Tableau should be a very easy process. So don't let that get in the way if you're not familiar with the tool that a particular company is using. Usually most companies understand that as well, and they've seen that to be the case.